This is FE Peer Review. The date is July the 24th, 2021. This is a review of a video by P900 Coolpics, the Beacon Hill to Isle of Man observation, which is essentially flawed. This review starts with a brief statement about atmospheric refraction and then moves on to examine some other aspects of P900's long-distance observation of the Isle of Man from Beacon Hill. In brief, P900's video is a long-distance observation that neglects to include atmospheric refraction. This is putting the cart before the horse. P900 may think that atmospheric refraction is not a phenomenon that needs to be considered in long-distance observations. But current accepted science is that it does need to be considered. So if P900 wants to conduct her observation while excluding it, she needs first to demonstrate that the current science on the subject is wrong, demonstrate that it can indeed be excluded from consideration, and only then analyze her observation while excluding it. So long as she has not demonstrated that the current science on atmospheric refraction is wrong, there is no basis for excluding it from her observation. In fact, not only must she demonstrate that including atmospheric refraction is wrong, this conclusion must be reviewed and accepted by the broader scientific community before she can ignore it and not expect to be criticized for doing so. As evidence that atmospheric refraction is indeed current accepted science and must be considered for long-distance observations, I'm including in the description of this video links to several scientific research papers and instruction manuals prepared by and for the U.S. military and other organizations, which discuss how refraction works and how it needs to be accounted for when conducting various activities. We'll look into that a bit further at the end of this video, but first there are some other issues. Starting at 0 minutes 10 seconds to 2 minutes 18 seconds, the author, P900 Coolpics, zooms in and out, focusing on the same peak several times, and tells us this peak is South Barul, this one here. But no other peaks are visible, and South Barul is significantly lower than the tallest peak on the Isle of Man, Snaefell. My first reaction when I saw that was to question whether we were looking at actually seeing South Barul here or whether we were seeing Snaefell, and it took me a while to decipher that, and I decided yes, indeed, we are seeing South Barul. We have the bottom of the image here, a little tower-like structure and a block. Let me see if I can bring that into a little better view. This little tower and then this block here, and then off to the far left of the image, another tower. I determined that these were landmarks in Fleetwood, and that from the Beacon Hill observation point, they did align with South Barul. So it became clear to me that yes, indeed, we are seeing South Barul, but that's all we're seeing. South Barul. There are, I think, 4 or maybe 5 other peaks on the Isle of Man that are higher than South Barul. In fact, I have a map here. I'll bring that up. Here's a little map. It's conveniently color-coded, so it's easy to read. South Barul is down at the bottom. We have, forgive my pronunciation, I have no idea how these names are pronounced, Slough Rye, which is a little bit lower than South Barul, hardly any. Colden, you can call that whatever you want, Snaefell, and North Barul. These are all higher than South Barul, and yet we are only seeing one peak here. Let's continue to go out a little bit. Now, South Barul, being the southernmost peak, all those other peaks I just mentioned would be to the right on the horizon. We see absolutely nothing all the way across. Still nothing. There's South Barul. By the way, I should say P900 did a really good job of zooming and panning smoothly to make it easier to watch. Anyway, still nothing. There we get the first glimpse of something to the north of South Barul. So from my mouse on the right all the way over to there, we have nothing visible of the Isle of Man. On the left here we have South Barrule. Here's Fleetwood below it. And at the far right we have the first hint of the rest of the island. We can see a little more of the island here now. Looking back at our map, we see that there is a low point, and looking at a topographic map, I'll show you in a moment, it drops down to about 50 meters elevation all the way across the island. Taking a look at Google Earth, I've drawn sight lines from the observer at Beacon Hill. I'll zoom in there so we can see where that is. I used P900's coordinates to establish the observation point. And I drew a sight line to Snaefell, which is the tallest peak, South Barrule, and that low area in between the road connecting Douglas and Peel. That would be the road connecting Douglas and Peel right there. We see from the pale green color that it's a low point. And one more thing I want to share with people here. This is a very good website. You know, some of the elevation data in Google Earth, when you're just mousing over the landscape and it's giving you elevation data, it's not all that accurate. Google Earth is very accurate in a lot of respects, but it's a little bit off with some of the elevation data when you get it that way by simply mousing over the surface of the ground. So when I'm checking on elevations, I like to look for other more reliable sources. This is a good website for that, by the way. It gives topographic lines. And we can see that the road is at around 50-meter elevation here. So there's a whole bunch of stuff missing between South Barrule and the first sign of more hills to the north, more peaks to the north. Where has all that gone? Let's back up a little bit. Nothing visible. Just horizon, nothing visible. I think that P900 Coolpics ought to ask herself that question. Why is she seeing only the tops of the peaks here and nothing between them? Seems to me a relevant question. In the next part of this video, I plan to analyze this image myself using P900 Coolpics data. I guess her name is Sandra. I'll call her Sandra. Using the data provided on the screen here, but factoring in currently accepted science on refraction to see what results that gives us as well. But before I go into that, I want to mention one other thing about this video, which I find a little bit disturbing. It's actually two separate observations. We have this first observation here from Beacon Hill, and then the second part of the video moves on to another view. And what bothers me about this is that there really wasn't any indication that this was another view, and I've come to the conclusion it's either on a day with very different atmospheric conditions, or it's from a different observer location entirely, and that information wasn't included in the video. So it's really easy to misunderstand what we're seeing here and think that we're seeing the same view, the same place from the same location at the same time, and we're not. We can't be. I don't understand how we possibly could be. If we are, I think it would be really great if Sandra could explain what's going on here. And I mention that because as we saw in the earlier image, there was a big gap between the peaks, and we saw horizon all the way across. In this part of the video, we are seeing more of the peaks. We are seeing some of this low land over to the right, to the north of the northernmost peaks of Isle of Man, and we are panning across and seeing the full island. Okay, that's the end of the panning. So I'm going to back up a little bit. So we get the full view all the way across. No gaps between the peaks and no horizon. This is not the same view as we saw in the first half of the video. And this very much resembles views I have seen taken from the waterfront at Barrow-on-Furness. So I think this second observation is done from a different location entirely. We are seeing more of the mountains. We are either at a higher elevation, or we are closer, or if it is taken from the same location, we're seeing much, much more looming due to very different atmospheric conditions. So different that they must have been on a different day. That really needs to be clarified. As it stands, this whole second half of the video is deceptive, or at the very least confusing, because the data behind the images is not provided. I think there's a tendency on the part of some people to assume it's the same data as the previous. That needs to be taken care of. That needs to be addressed. Okay, let's take a quick look now at that same observation, Beacon Hill to the Isle of Man, with and without refraction. I have here on the screen Google Earth. Our observer location is at the bottom right of the screen, Beacon Hill, 217-meter elevation. I got that elevation data from P900 Coolpics video. On the left we have the Isle of Man, and I've indicated some of the peaks, and I've got their elevations, which I took from sources such as Wikipedia. That topographic map is the one I went to finally, that I showed earlier. So we have a red line connecting the observer to South Barul. That's the bottom of the three red lines. And that red line I've named, that's a path I've named Beacon to South Barul, 134 kilometers. So now we have our two elevations and our distance between. We will put those into a curve calculator here, which gives where we can put an observer height of 217 meters, a target height of 483. I want to double check that. Yes, 483. And a target distance of 134,000 meters, 134 kilometers. I'm doing everything in metric just to keep it all in one reference. And, oh, there's nothing there. Nothing there. Okay, well, let's see. We are looking at zero refraction. What happens when we turn on standard refraction? Oh, there's something. We are seeing 102 meters, and 180 is hidden. So we're seeing approximately 1/5 of the total height. So what we see here continues down 4 more times. That would be at standard refraction. And I'll just pull the button all the way over and you can see that there's a lot more there. But back to standard. So, what do we find? At that elevation at Beacon Hill, we look out on a certain day and we do see South Barul. But we don't see anything to the north of it. We see horizon. We don't see nothing, which is what would be the case on a smooth sphere with no atmosphere. We indeed see something, but we do not see everything. Now let's take a look at Snaefell, the tallest peak. We have Snaefell here, where I'm circling the mouse, our same observer point. We have a path distance of Beacon to Snaefell, 125 kilometers. So Snaefell 621 and 125. 621 and 125. We'll set it to standard again. And we see quite a bit. We see a little more than half, which is what we see off to the right as we pan out. So there are the mountains of the northern part of the island off to the right. We're seeing them. We're seeing bare horizon with nothing, and then we're seeing a mountain at the south, a peak at the south. Now that's what looking at it and factoring in refraction gives us. So what we see matches the globe model without any problems whatsoever. The question is purely, is refraction a real phenomenon or not? And for that, I refer you back to the start of this video where I provided, I think I showed the covers of four papers there. I have several more to add to the list. I'll put them all in the description. These are all scientific papers that were prepared for organizations like the U.S. military, which uses them for radar and for visual targeting. Industries like telecommunications that use them for communicating. And all these industries and organizations have incorporated atmospheric refraction into their work. So if we've got it wrong and there's no such thing, Sandra needs to come up with a scientific answer based on observation of natural phenomena, calculated and tested, to challenge all those papers, not even just one of them, but all of them. They have to all be shown to be wrong, and we have to be presented with a more correct, more accurate, more effective solution. By effective, I mean able to create predictions that turn out to be correct, able to create technology that turns out to be useful for communicating around the world. This is what you need to do. You just can't ignore it and pretend like it's not there and think that you've proven anything at all. You're in an echo chamber. You're getting the attaboys of all your buddies who want to think the same thing, but you've actually done nothing. No progress. You've learned nothing. The world has gained nothing by this. So read those papers, all of them. Understand them. Study until you understand them. Because if they're wrong, if those papers are wrong, you're not going to be able to prove they're wrong unless you understand them. Unless you can show where they're wrong. That's your challenge, Sandra. We don't need more pictures with a P900 or a P1000 or whatever it is you use these days. We need solid science that debunks all that atmospheric refraction nonsense. Good luck with that project. Before I close, I want to say one last thing. Sandra, so there's the whole problem of proving that atmospheric refraction science is wrong, but there's also another problem. I look at this picture and I see a peak there. It has a very distinctive profile. I can compare that to the peak of South Barul, and I can see that indeed it matches the upper 100 or so meters of the profile of South Barul, but that's all I see. And then there's this big horizon, and I don't see anything below that top 100 meters. Where did it all go? We know it's there. If the Earth is not a sphere, if it's flat, why don't we see it when we zoom in like this? Why does it not appear back up above the horizon again? Why is it that to the north of South Barul, all we see is the flat line of water? An explanation is required. I mean, this just doesn't quite make sense. Don't you think that it's a reasonable question to ask? So what's your answer? Why do we see nothing? And what's the basis for your answer? What's the observed evidence, the measured evidence, and the evidence that will allow us to predict with future observations of other locations what we will see? Well, you've got some work ahead of you. Wish you the best of luck figuring out the answers to those questions. And as far as the rest of you watching this video, I wish you all a great day. Do the usual, please, if you don't mind. A little thumbs up is great, and a subscribe is also nice. Have a great day. Bye-bye.